So hi everyone and welcome to week 6 on retrofitting. This short video is going to briefly introduce the EnerPHit Standard, which is the passive house standard for retrofitting buildings. The EnerPHit Standard was developed by the Passive House Institute as the Passive House Certificate for retrofitted buildings. It was developed given that there are challenges in retrofitting buildings that mean that it is not always possible to achieve the passive house standard of new constructions. So these challenges include technical challenges relating to the building's structural form, its orientation, difficulties in addressing thermal bridges in existing buildings, and addressing airtightness, as well as other barriers relating to conservation and planning restrictions, for example. As a result, the EnerPHit standard for retrofitting is a heating demand of 20 to 25 kWh per metre squared per year, depending on the climate, compared to the stricter passive house standard of a heating demand of 15 kWh per metre squared per year or less. As with passive house design, the EnerPHit standard can be achieved by applying the 5 key principles of passive house. So that means focusing on thermally insulating the building, using passive house windows, implementing an adequate ventilation strategy, focusing on airtightness, and removing thermal bridges through design. So achieving the EnerPHit standard can have economic benefits. It can also result in an improved indoor environment through thermal comfort improvements, improved air quality, no mold growth, and a constant supply of fresh air. And it can also have significant space heating demand reductions as well as CO2 emission reductions. As well as that, the EnerPHit certification process offers a documented quality assurance and acts as an important opportunity to apply higher quality and higher efficiency measures than you would otherwise have considered. And it also acts as an incentive for building owners to strive for a higher energy efficiency standard than they would otherwise have considered. So PHPP is used to determine the energy performance of the retrofitted building, and there are two ways that you can fulfill the EnerPHit criteria. So that's by component or by energy demand. In the component method, each component of the building, so for example your insulation, your windows, your ventilation system, must comply with a limiting value that's set out in the criteria and comply on airtightness and primary energy demand criteria. In the energy demand method, the retrofitted building should meet a certain energy demand that's specific to the climate zone. So you can see that for the component criteria, specific heat transfer coefficients are presented for each envelope component, as well as for the windows, while minimum heat recovery rates and humidity recovery rates where relevant are specified across the different climate zones according to the PHPP. Ireland would be considered a cool and temperate climate, and therefore you would comply with those values specified for this climate zone. So alternatively, you can use the energy demand criteria, and again, these are specific to the climate zone. So again, for Ireland, you would look at the cool temperate climate, and therefore you'd see that the max heating demand for an EnerPHit standard in Ireland would be 25 kWh per metre squared per annum. So there are some exemptions specified in section 2.2.4 of the criteria for buildings that, where applicable, allow the heat transfer coefficients of the external envelope to be exceeded. So that includes things like legal requirements, if it's a historical building, if the required measures aren't cost effective, if the required insulation level restricts the building's use or the surrounding areas, if there aren't components available that comply on both EnerPHit criteria and other requirements, so it could be fire safety, if thinner insulation is required in the case of interior insulation to avoid moisture damage, or if there's an other compelling reason related to the construction of the building. So regardless if you're using the component or energy demand method to fulfill the EnerPHit criteria, you must always comply on airtightness and primary energy demand criteria. So for airtightness, that includes a pressurization test result of less than or equal to 1 air changes per hour. So that is less strict than the passive house standard requirement of 0.6 air changes per hour. And the renewable primary energy demand criteria are the same as set out in the passive house standard. So both passive house and EnerPHit buildings offer optimum standards of thermal comfort, user satisfaction, and protection against moisture damage. And so there are minimum criteria set out in section 2.4 of the criteria for buildings that both EnerPHit and passive house buildings must meet. And so that includes requirements relating to the frequency of overheating in the building, the frequency of excessively high humidity levels, ventilation criteria relating to volumetric flow rates, controllability, humidity levels, sound level and any drafts, minimum thermal comfort criteria, moisture protection criteria and occupant satisfaction criteria. So within PHPP, you can specify in the project settings whether you'll be dealing with a new building or a retrofit, and whether you plan to achieve the energy standard through the energy demand method or the component criteria highlighted here. As well as that, you can specify if you're achieving the EnerPHit standard through a complete retrofit or through a staged retrofit. So a complete retrofit would have benefits in that occupants only have to bear the disruption of the works once, compared if they were doing works in a staged manner. However, a step-by-step retrofit has its own benefits in that the costs can be spread out over time without compromising on quality. If you are doing a step-by-step retrofit by built-in component, you might first look at replacing the windows, addressing air tightness and installing your ventilation system. Then later, as another step, you might insulate the building, and then finally move on to installing your new heating systems and renewable energy systems to finally achieve the EnerPHit standard. Or you might focus on retrofitting certain built-in parts or sections, so that might be the case for apartments or terraced houses. Regardless of what you do, the most important thing is to consider the challenges of a step-by-step retrofit. So that includes keeping any interdependencies between the retrofit measures in mind. So that could be any interdependencies between the connection details and the chronological order of the measures, or any functional dependencies between the measures to avoid lock-in effects. Therefore, an overall concept and plan is essential to conducting a step-by-step retrofit. So the EnerPHit retrofit plan is the overall plan for step-by-step retrofits. It is a document for built-in owners that takes into account all of the interrelationships between the different energy-saving measures and allows an optimal final result to be achieved. So the ERP is generated based on imports from the completed PHPP file, and it contains useful information on all the measures as well as the overall energy improvements of each step. And it is a prerequisite for the EnerPHit pre-certification process, which can be obtained in the case of step-by-step retrofits. So pre-certification verifies the possibility that the plan outlined will achieve the EnerPHit standard when it is complete. So to achieve pre-certification, you must first have your ERP submitted, and the first step of the retrofit must be complete as per specified in the ERP, and the primary energy demand must have reduced significantly from the initial state. Then once pre-certification is obtained, the rest of the works can be completed as per the plan, and then finally the EnerPHit standard will be achieved.